Hello, and welcome back to another video in our Introduction to Computer Graphics series. In today's video, we are delving into the fascinating world of vector graphics and exploring the fundamentals that make them an integral part of our digital lives. Vector graphics are everywhere in our daily lives, whether you're watching TV, using your mobile phone, or looking at beautifully designed banners, you're probably witnessing vector graphics in action. But what are vector graphics and what are their applications? Vector graphics are a type of computer graphics that use mathematical formulas to define and render smooth, scalable shapes. In other words, they are all about precision and perfection in design. These graphics find their applications in everything from logos to fonts, creating these elegant, smoothly curved shapes that we encounter on the web and our screens. Today, we are going to explore our essential element of vector graphics, Bezier curves. In particular, we focus on their use in scalable vector graphics, also known as SVGs. So, how do we start our journey into Bezier curves? Imagine 2 points P0 and P1. Now connect them with a straight line. Let's introduce a third point P which lies between P0 and P1. We can control P's position using a weight which we'll call T. When T is 0, P is at P0. When T is 1, P is at P1, and any value in between represents a blend between the 2 points. This process is known as linear interpolation, denoted as lerp and written as 1 minus tp0 plus tp1. As you change the value of t from 0 to 1, you will notice that p follows a straight line known as linear Bezier curve or a line segment. Now let's add another dimension. Take 3 points P0, P1 and P2 and connect them with lines. Then we'll introduce 2 points A and B, each lerping along these lines. Finally, introduce another point P which lerps between A and B. As the as you vary the universal t value from 0 to 1, the P traces a curved path forming a quadratic Bezier curve. Here P0 and P2 are the endpoints and P1 is the handle. Taking it a step further, we involve 4 points P0, P1, P2, and P3 connected by lines. Three additional points A, P, and C lerp along these lines. We then connect A, P, and C with two more points D and E, which also lerp between these points. A point P lerps between D and E, adjusting the t value from 0 to 1. You'll observe p following a distinctive path, creating a cubic Bezier curve. This is the most common type of curve used in computer graphics. Now we have established that P lerps between D and E lerp between A and B and C, and A, B, and C lerp between P0 and P1, P1 and P2, and P2 and P3. We can describe an equation to calculate P's position. Let's write these relations down in their linear form. Now we will replace these variables with their corresponding values. Step by step, we'll end up with a complex equation which we'll simplify by taking common factors of p0, p1, p2 and p3. The final equation we arrive at is a cubic polynomial that represents the position of p. It can be written as shown. This equation defines the path of p as t varies from 0 to 1, creating a beautiful cubic Bezier curve.
Creating a Bezier curve in p5.js is very simple. First we need to declare 4 variables p0, p1, p2 and p3. Next we need to initialize all of these variables to random values. This is done using the create vector function. In this function we input the x and y value of the vector. Next we will draw 4 points on p0, p1, p2 and p3's position. The point function takes two inputs x and y position of the point. As we can see that the points are not being visualized. We need to declare a stroke color and a stroke weight. The stroke color is just like the fill, but it defines the outline, and stroke weight defines the width of the outline. Now we are seeing 4 points on the canvas. To draw a Bezier curve, we just use the Bezier function. It takes 8 inputs, position of the first, second, third and fourth points. We can use the no fill function to only show the outline of the Bezier curve. We can increase the stroke weight of the points, and now we would like to move the points using our mouse. To do this, we will use the if function to check if the distance between the mouse and the point is below a specific value. The distance is measured using the distance function. It takes 4 inputs, the x and y of the first point and the x and y of the second point. If such a condition is true, then we move the point to mouse's position. Then we repeat this function for all of the points. Now we can see that the points are moving with the mouse, but we also need to change the stroke weight of the Bezier curve. Then we will add the mouse press condition to all of these to check if the mouse is pressed, and then move the points. Now you have created a basic Bezier curve function in p5.js. I hope that you find this video useful, and thank you for watching.